Chapter 7 Review Part 1. In this video we are going to review Section 7.1 and 7.2, the normal distribution and the standard normal distribution. Lesson objectives: find the area under the standard normal curve, interpret the area under the standard normal curve as a probability. Let's look at some properties of the normal density curve or the normal distribution. It's symmetric about the mean, mu. Because the mean, the median, the mode all equal the same number, there is a single peak, and the highest point occurs at x equals mu. It has inflection points at mu minus sigma and mu plus sigma. The area under the curve is 1. The area under the curve to the right of mu equals the area under the curve to the left of mu, which both equal 1/2. As x increases without bound, gets larger and larger, the graph approaches, but it never does touch the horizontal axis. As x decreases without bound, gets larger and larger in the negative direction, the graph approaches, but never touches the horizontal axis. And number 7, the empirical rule. 68% will be within 1 standard deviation of the mean, 95% will be 2 standard deviations above or below the mean, and 3 standard deviations will contain approximately 99.7% of the data. In this video we're going to use Table 5, and Table 5 is more precise than the empirical rule, as we'll see. Table 5. There are 3 locations for Table 5 on pages A11 and A12 in the book, on the 2 pages on the back cover, and also on the formula card. Table 5 gives the area under the standard normal curve for values to the left of the z-score, as we see in this figure. Table 5 always gives us area to the left. Here's some rules for using Table 5. First of all, we always want to draw a picture. We want to keep in mind that the table gives us the area, which is the same thing as probability, to the left of the z-score. We calculate all z-scores to the thousandths place, and then we round them back to the hundredths place, which is 2 decimal places. We use the column component and the row component of the z-score to find area or probability values. The table entry at the junction of the column and row components is the desired left area value. Left area or probability values for z-scores with values that are less than 3.49 are going to be used this default number 0.0001, and left area or probability values for z-scores greater than 3.49 we're going to use the default 0.9999. Now let's get a visual of this. So here's Table 5. If we want to find the z-score that are less than negative 3.49, we see the table stops at 0.0002. Any z-score less than negative 3.49, we're going to use the default 0.0001. And on the high end, the bottom of the table, we see that the largest z-score is 3.49, which has a probability of 0.9998. So any z-score larger than 3.49, we're going to use the default 0.9999. Let's do an example. Find the area under the standard normal curve to the left of negative 0.38. So the first thing we want to do is draw our picture. Negative 0.38 is going to be to the left of the mean. We draw our picture. We want the area to the left, so we color that in. So just by looking at our picture, we know the value should be less than 0.5. So using Table 5, we first go to a negative 0.3. And then for the column component, we go to 0.08, which is here. And where these two intersect, that will be our answer, 0.3520. So the area to the left of the z-score, negative 0.38, is 0.3520, which agrees with our picture. The value should be less than 0.5, and it is. Let's do another example. Find the area to the left of z equals 0.61. This time the z is positive, so it goes above 0. And we want the area to the left. So just from the picture we know that the answer is going to be more than 0.5 because anything left of 0 is 0.5, and this contains a larger area. So we take table 5. We first go to the row component, positive 0.6, and then we go to the column component, which is 0.01, which is in this column. And where these two intersect, we see that the probability or the area is 0.7291. And that agrees with our picture. It should be larger than 0.5, and it is. Now if we're wanting to find the area to the right of a z-score, we have to do 1 minus the area to the left of the z-score. Let's do an example. Find the area under the standard normal curve to the right of z equals 1.25. Now 1.25 is in the positive direction, it's above the mean, and this time we want the area to the right. Table 5 gives us the area to the left. So once we find this value, we simply do 1 minus, and that will give us the desired area or probability. Looking at table 5, we first start with the row component, 1.2, positive, and then we go to the column component, which is 0.05, which is in this column. Where they intersect is 0.8944. Now that's the area to the left. Since we want the area to the right, we have to do 1 minus, and 1 minus 0.8944 is 0.1056, and that agrees with our picture. It should be less than 0.5, and it is. Now let's do another example involving the area in between two z-scores. First thing we do is draw a picture. Here we have a negative 1.02 and a positive 2.94. Now what we're going to do in table 5 is we're going to find the area to the left of this z-score, negative 1.02, and the area to the left of 2.94, and then we're going to subtract these two areas, and that will give us the desired shaded region. So the area to the left of negative 0.02 is 0.1539. The area to the left of a z-score of 2.94 is 0.9984. And if we take these two areas and subtract them, again always the largest area minus the smallest, we get 0.8445. So let's review. If we are wanting to find the area to the left of a z-score, we just go to table 5 and look in the table, and that will give us area to the left. If we want to find the area to the right of a z-score, we look up that value in table 5 and we do 1 minus what table 5 gives us. And if we want to find in between two z-scores, we find the area to the left of the largest z-score, and we find the area to the left of the smallest z-score, and we subtract the area of the largest z-score minus the area of the smallest z-score. Here's some things to keep in mind. Don't confuse z-scores and areas. Z-scores are distances along the horizontal scale, but the areas are regions under the normal curve. Table 5 lists z-scores in the left column and across the top row, but the areas are found in the body of the table. Choose the correct left or right side of the graph. Z-scores can be positive or negative. A z-score must be negative whenever it's located in the left half of the distribution, and a positive z-score must be located in the right half of the normal distribution. Areas, which is the same thing as probabilities, are positive. They can never be negative. Z-scores can be negative, z-scores can be positive, but the areas or the probabilities are always positive. Thanks for watching.